What's up, guys? Let's take a look at Advent of Code Day 2. This one's called Cube Conundrum. We've got this game where we reach into a bag and pull out some dice, and although that may remind you of some probability problems, this one is looking for something different. This one is looking for the maximum that we've seen of each color. If I reach into a bag and pull out 7 greens, well, I know there are at least 7 greens. There may still be more in the bag. And if I replace those, and later I reach in and find 9 green, well, now 9 is my new maximum estimate for how many greens there are. They give us these hard limits, and if at any point during a game, in any grab, I get something higher than one of those, the game wasn't real, didn't happen, it's disqualified. So the game has an ID number here, and then it's got multiple runs, multiple times when you go in and grab a sample, separated by semicolons, which means like on this one, we've got 4 red, and that's the highest, so there have to be at least 4 red. Right here we got 3 blue, and that's not the highest, because later I get 6. So 6 is my estimate for the max blues in that whole series. And this one was fun to think about, but it wasn't super fun to type, so I'm going to skip some of that and bring up part 1 already here. You won't have to hear the click-clack of me doing it, but you will hear me explain it, and then I'll show part 2, which is a variation. We've got our big data, we've got our test data, and we've got our limits, which I put in all caps because they're a constant applying to the whole world. Then I say, okay, part 1, we've got our total. By the way, what they're asking for is the game IDs added up. So in this one, games 3 and 4 were disqualified because they had some that went over the hard limits. So we take 1, 2, and 5, and we get 8. Let's give that a shot. I'm going to run it just to show you. And we do, in fact, get 8. How does that work? Well, first I need to take the line and parse it just a little bit into the different sections. We got the game and the number. We need to keep that because we need to use it for the total. And then we got the rest of the stuff all in a list. So I say, head and tail, we split by the colon. And then to find the game number, I started out by taking just 2 digits to the left of the colon, and that worked all the way until the very last one. There's a 3-digit number, and I got the wrong answer. Took me a minute to figure that out. And then, which by the way, this is exactly the same as I typed yesterday on one of these where we had to get the digits out of something. And then subsets, I have a list of these guys split by the semicolon. We'll have to split them up more later when we dig into the details of each color, but that's a good start. And so we parse that, and then I got this big old line which looks pretty complicated. But what does it do? It says, hey, this limit thing is a dictionary, and then when we look through the games, we're going to make another dictionary of the biggest one we've seen from each color. So I don't have to remember everything we've seen, I just have to remember the biggest one. 4 red is the biggest one we've ever seen in that game, so red 4 is our max. 3 blue is not, so I can forget about it as soon as I see the 6 blue. And so I end up, after looking through this whole thing, with red 4, blue 6, green whatever. And how do we get that? Well, I start off with a 0 for each one, because I think in theory we could have a game where you never see a color, and so we might have blue 0 even after looking through it. And then for each one of these, because it happens, we have multiple runs per game, we split them up a little bit more. And whenever I write stuff like this, I feel like, okay, I should probably learn regular expressions, right, to split up the string in a few ways, but so far I'm just splitting on the comma to get chunks like this, and then I'm splitting on the space to get like the name and the amount separately. So I call that count and color, name and amount, whatever. And then the maximum is the max of whatever it had and the new amount. So if the new amount was more, like when we had the 6 blue after the 3 blue, well, now it takes that spot. And if the old one was more, well, it's still in there because it's the max. I like that because I don't have to use names. I don't have to say like something equals int count and then use the something and blah, blah, blah. No problem. So then we return that, and so we have a dictionary, which is like the biggest one we've seen in each game. And then I say if any of those gives us the max is bigger than the limit, when we zip the limits and the maxes together, then it's not in. It doesn't qualify. It wasn't real. It doesn't go to the total. This is using zip, and now that I think about it, I could have just gone with a list or a tuple because RGB is pretty standard. We don't need to call it red, green, and blue. We understand that the first thing in a color is the red and the second thing is the green. But I ended up making them as dictionaries, so we got to call the dot values method to get just that part and not the names. So now if I run that on the whole thing, then we get 2771. I remember getting 2671 when I didn't know about the 100 thing, so I remember that number. And that was in fact the answer for part 1. Part 2 says, what is the lowest that the limit could be? So we've got these limits of like red 12, but if red never hits 12, then it could have been less, right? Or green 13, but if green, like here, green only ever gets to 2, so the limit could have been 2. And here, blue only ever gets to 6, so it could have been 6. So this one in part 2 is asking, what's the lowest that the limits could have been? And that is so incredibly similar to part 1, at least the way I did part 1. I think I just got lucky not knowing that that was going to be next. I just made the stuff that worked anyway. So for example, the maxima is what we need. Like I don't have to make a minima because we're actually looking for the highest the color goes, which is where the limit would meet it on the way down. And so I can use that in part 2. So I'm going to say actually I'm going to copy this because it's pretty darn similar. This is the only part that changes, right? Because we still have a total, and we're going to add something up along the way according to the parsed lines, and we just have to fill in a different thing for that action. I'm sure you could, if you wanted to, use the sum function, and so say like sum of this big thing for this and this, blah, blah, blah. But we've already got a big old expression here. I wouldn't want to have that inside another one, inside another one. So let's say, what do we need to do? I got to read the rest of the instructions because I didn't tell you what they're asking for. The power is like the RGB product multiplied by each other with the lowest that the limits could have been. So like on the first one, 4 red, 2 green, and 6 blue is that maximum dictionary that I was talking about, which also just happens to be the lowest limit that they're talking about because they meet at those numbers. So what are we going to do? I'm going to make one little baby function for that product because I love making a function and then being able to call it here with somewhat readable expressiveness. I know that is not particularly nice, but it would have been worse if I didn't name the parts, right? So I'm going to say RGB equals colors dot values. So I'm going to give it a dictionary of the red, green, blue maxima, and then I'm going to return R times G times B. I think you can do like import math.prod or something to do the product, but I don't mind typing 2 stars. And then So we're going to go total plus equals product of, I called it game maxima of subsets. Okay, and now let's do that on the test data to see if we're on the right track before we do the big data. It says 2286, is that right? Yeah, 2286, because we take like the smallest the limits could be, and the same for all the other guys. So now we got to do that with the big data, the lines, and we get 70924, which is in fact the right answer that I got when I tried this a little earlier. This was a really fun one, and I hope the video is fun. I'm not sure if it's better to prepare it beforehand and just try to describe what I'm describing here, or if it's better to type it live and you get to watch that. Sometimes I think it's the most annoying thing in the world to just sit there while somebody click-clacks. Other times I think, well, that's the only part that matters because it's the only part that's real, is to actually see the work. So I'm not sure. If any human out there watches this, let me know which you would prefer. Thanks.